Good day, students. Welcome to JSS 2 Basic Science, Term 3, Week 2. Today we study acids, bases, and indicators, one of the most colorful and practical topics in junior secondary chemistry. Acids and bases are found all around you in everyday Nigerian life: the acid in your stomach that digests food, the lemon juice you squeeze on rice, the baking soda, sodium bicarbonate, your mother uses in cooking, the soap she makes from lye, sodium hydroxide, and palm kernel oil. Understanding these substances helps you make sense of biology, chemistry, and even food science. By the end of this lesson, you will be able to define acids, bases, and salts, identify properties of acids and bases, describe how indicators work and name common indicators, use the pH scale, and give everyday Nigerian examples of acids, bases, and salts. Let us test our chemical knowledge. An acid is a substance that produces hydrogen ions, H, when dissolved in water, tastes sour, turns blue litmus red, has a pH less than 7, reacts with metals to produce hydrogen gas, reacts with bases to form salt and water, neutralization. Examples: hydrochloric acid, HCl, in your stomach as gastric acid, sulfuric acid, H2SO4, in car batteries, nitric acid, HNO3, used in fertilizer production, organic, weak, acids found in food, citric acid, in lime, orange, and lemon, common Nigerian fruits, ethanoic/acetic acid, in vinegar used in suya pepper and salads, lactic acid, in yogurt and fermented ogi/akamu. A base is a substance that is the chemical opposite of an acid, reacts with acids to neutralize them, produces hydroxide ions, OH, when dissolved in water. An alkali is a base that dissolves in water. All alkalis are bases, but not all bases are alkalis. Properties: feel soapy or slippery to the touch, taste bitter, turns red litmus blue, has a pH greater than 7. Examples: sodium hydroxide, NaOH, caustic soda/lye, used to make soap from palm kernel oil, potassium hydroxide, KOH, calcium hydroxide, CaOH2, slaked lime, used in building, soil liming, sodium bicarbonate, NaHCO3, baking soda, ammonia solution, NH3 in water. A salt is formed when an acid reacts with a base, neutralization. The H from the acid combines with the OH from the base to form water, the remaining ions combine to form the salt. The pH scale measures acidity/alkalinity on a scale from 0 to 14. pH 0 to 6, acid, pH 0 equals most acidic. pH 7, neutral. pH 8 to 14, alkaline/basic, pH 14 equals most alkaline. Each pH unit represents a 10-fold difference in acidity. Section 1, Properties of acids. Physical: generally liquid at room temperature, may have sharp smell, e.g., vinegar, HCl gas, sour taste, never taste. Lab acids, they are corrosive and dangerous. Chemical: react with metals, more reactive ones like zinc, iron, magnesium acid plus metal salt plus hydrogen gas. Example: HCl plus Mg, MgCl2 plus H2. Test for hydrogen gas, burning splint test, H2 burns with a squeaky pop. React with carbonates, acid plus carbonate, salt plus water plus CO2 gas. Example: HCl plus CaCO3, CaCl2 plus H2O plus CO2. Test for CO2, passes CO2 through lime water turns milky, chalky. React with bases, neutralization, acid plus base, salt plus water. Nigerian examples of acids: lime/lemon juice, citric acid, pH is almost equal to 2, used in cooking, drinks, tomatoes, citric, malic acid, used in Nigerian stews, tamarind, tartaric acid, used in zobo, hibiscus, drink, orange juice, citric acid, common Nigerian fruit, vinegar, ethanoic acid, used as preservative, sour milk, lactic acid, in fermented dairy, car battery acid, sulfuric acid, in lead-acid batteries. Section 2, Properties of bases/alkalis. Physical: solids, NaOH, Ca, or OH2, or solutions, aqueous NH3, feel slippery/soapy, due to saponification of skin oils, not a safe test with strong alkalis. Chemical, react with acids, neutralization, react with ammonium salts when heated to produce ammonia gas, react with fats/oils to produce soap, saponification. This is the basis of traditional Nigerian soap making, using cocoa pod ash as a source of KOH plus palm kernel oil. Strong alkalis are corrosive. NaOH dissolves organic matter, skin, fats, hence used in drain cleaners. Nigerian examples of alkalis/bases: baking soda, NaOHCO3, in bread, akara batter, makes akara fluffy, egg white, slightly alkaline, cocoa pod ash solution, contains K2CO3 and KOH, used in traditional West African soap making, toothpaste, slightly alkaline, pH is almost equal to 8, to neutralize mouth acids that cause tooth decay, seawater, slightly alkaline, pH is almost equal to 8.3, antacids e.g., Gaviscon, Andrews liver salts, milk of magnesia, alkaline substances taken to neutralize excess stomach acid, heartburn. Treatment. Section 3, Indicators. An indicator is a substance that changes color depending on whether a solution is acidic or alkaline. They are used to test the pH of solutions. Common indicators. 1. Litmus, from lichens. Blue litmus turns red in acid, red litmus turns blue in alkali, purple/neutral in neutral solution. Available as litmus paper, red or blue strips, or litmus solution. 2. Metal orange, red in acid, yellow in alkali, orange at neutral, pH 3.1 to 4.4 range. 3. Phenolphthalein, colorless in acid and neutral, pink/magenta in alkali, pH 8.2 to 10.0 range. 4. Universal indicator, a mixture of several indicators, gives a range of colors across the full pH spectrum, from red/orange, pH 1 to 3, through green, pH 7 neutral, to purple/dark blue, pH 13 to 14, sold as paper strips or solution. 5. Natural indicators, very important for the lab in Nigerian schools where commercial indicators may be unavailable. Red cabbage extract, acidic solutions red/pink, neutral purple, alkaline green/yellow. Turmeric, yellow spice yellow in neutral/acid, red-orange in strong alkali. This is why turmeric stains in cooking equipment may turn red when washed with alkaline detergent. Purple/red hibiscus, zobo, flowers, pink in acid, green in alkali. Beetroot juice, similar color changes. These natural indicators are excellent for school laboratory experiments using everyday Nigerian materials. Section 4, Neutralization and its applications. Neutralization, acid plus base salt plus water. The H ions from the acid combine with the OH ions from the base, H plus OH H2O. Applications of neutralization in Nigerian context. 1. Antacids. When your stomach produces too much HCl, causing heartburn or ulcers, antacids, containing Mg, OH2, Al, OH3, or NaOHCO3, are taken to neutralize the excess acid. NaOHCO3 plus HCl NaCl plus H2O plus CO2, this produces the fizzing sensation. 2. Soil liming. When Nigerian farmland soil becomes too acidic, pH below 6 reduces crop yields, farmers add crushed limestone, CaCO3, or slaked lime, CaOH2, to neutralize the acidity and raise pH. Very important for cocoa and cassava farming in the southwest and southeast. 3. Treating stings and bites. Wasp stings are alkaline, treat with a weak acid, lemon juice. Bee stings are acidic, treat with a weak base, baking soda paste. Know the difference. 4. Soap making. NaOH, strong base, plus palm oil, fatty acid esters, sodium palmitate, soap plus glycerol. This is saponification. 5. Fertilizer production. HNO3 plus NH3 NH4NO3, ammonium nitrate, a key nitrogen fertilizer. HNO3 plus Ca, OH, 2Ca, NO3, 2, calcium nitrate, another fertilizer. Worked questions. Question 1. A solution turns blue litmus red and has a sour taste. What is its pH range and is it an acid or alkali? Answer: it is an acid. pH is less than 7, between 0 and 6. Turning blue litmus red and sour taste are both properties of acids. Question 2. Write the equation for the reaction of hydrochloric acid with calcium carbonate. Answer: 2HCl plus CaCO3 CaCl2 plus H2O plus CO2. Products: calcium chloride, salt, water, and carbon dioxide gas. CO2 is tested by passing through lime water. Lime water turns milky. Question 3. A Nigerian farmer notices his cassava yield has dropped. A soil test shows pH 4.5. What should he add and why? Answer: the farmer should add slaked lime, CaOH2, or crushed limestone, CaCO3. The soil is too acidic. pH 4.5 is well below the ideal pH range of 5.5 to 7 for cassava. Adding lime will neutralize the excess acid and raise the soil pH to a range more suitable for crop growth. For acid-base errors. Mistake 1. Saying all bases are alkalis. All alkalis are bases, but bases that do not dissolve in water, e.g., copper, 2, oxide, iron, 3, oxide, are not alkalis. Only water-soluble bases are alkalis. Mistake 2. Confusing pH and acidity direction. Lower pH means more acidic. pH 2 is more acidic than pH 5. Higher pH means more alkaline. Mistake 3. Treating all insect stings with the same remedy. Bee stings are acidic. Treat with alkali. Baking soda. Wasp stings are alkaline. Treat with acid, lemon juice/vinegar. Wrong remedy worsens the reaction. Mistake 4. Saying salt is always the table salt, at NaCl. In chemistry, a salt is any compound formed when an acid reacts with a base. NaCl is just one example. CaCl2, MgSO4, NH4NO3 are also salts. Brilliant work. Acids, pH below 7, sour taste, turn blue litmus red, react with metals, carbonates, bases. Nigerian examples: lime juice, tomatoes, stomach acid. Bases/alkalis, pH above 7, feel soapy, turn red litmus blue, react with acids. Neutralization. Nigerian examples: baking soda, antacids, cocoa pod ash. pH scale: 0 to 6, acid, 7, neutral, 8 to 14, alkaline. Indicators: litmus, blue/red, metal orange, red/yellow, phenolphthalein, colorless/pink. Universal indicator, natural indicators, red cabbage, turmeric, zobo. Neutralization: acid plus base, salt plus water, antacids for stomach acid, soil liming for acidic farmland, soap making, fertilizer production. For homework, use red cabbage juice as a natural indicator to test the pH of 5 liquids from your home, e.g., lime juice, water, soap solution, baking soda solution, vinegar. Record the color change and identify each as acid, neutral, or alkaline.